Hello, students. Today's lesson is about partial fraction decomposition, which sounds very impressive when you say it, but all it means is we're taking the sum of two rational expressions and we're trying to figure out what they were before we added them together. It's a little bit like factoring, but for addition, so it's kind of crazy that way. And I'm going to go through one example that has numbers in it. And this is based on, like, my kid just said, "Hey, Mom, I just added two fractions together. They were both reduced and they had different denominators, and I got 5/14. So he asked me what the two fractions were. Um, my idea, and I would really recommend that you pause this and try to get an answer because there's more than one answer that works. But this is it's kind of cool. So it's kind of interesting to think about. My idea was that maybe one of the denominators was 7 and one of the denominators was 2. And then I have an equation that has two variables and I would like to clear the fractions. So the way I do that is I'm multiply by the common denominator. So I'm going to multiply both sides of my equation by 14. On this side, my 14s are going to cancel and I'll get 5. And on the other side, I have to distribute 14. So 14a divided by 7 would be 2a. And then 14b divided by 2 would be 7b. And I'm looking for any numbers a and b that would work with that equation. There's more than one correct answer. And one of the correct answers is A is -1 and B is 1, because then you get 7 minus 1, which is 5. If that's the case, then the numbers that my kid added together were -1/7 and 1/2. And you can convince yourself by finding a common denominator that that is true, that those two numbers really do add up to 5/14. Of course, we're in the rational expression chapter, so we're going to do this same idea, but we're not going to do it with numbers. We're going to do it with expressions. With this example problem, it wasn't very satisfying because there's actually infinitely many ways to get an answer. With these problems, the rational expression problems, you're going to have only one possible answer. Okay, so here, this is on your note sheet. This is the first thing that you have that's on your note sheet. And the steps are, first, we're going to factor the denominator. So I'm going to look at this rational expression as 5x minus 1, and then I'm going to think about two numbers that multiply to be -15 and add to be -2. Because the number in front of x squared is just a 1, I know that I can jump right to my factors. So the two possibilities would be 5, which would have to be negative, plus 3. Okay, so now I'm going to write as the sum of those two fractions. So I'm going to write it as a over x minus 5 plus b over x plus 3. Okay, I should have another step in here, and I think you do on your note sheet. The next step is we're going to multiply by our common denominator to clear our fractions. So I'm going to multiply both sides of my equation by the common denominator, which is x minus 5 times x plus 3. On the left-hand side, I'm going to get, my denominators are going to cancel, so I just get 5x minus 1. On the right-hand side, I have to distribute, so I would get a times x minus 5, x plus 3 divided by x minus 5. So these x minus 5's cancel, and then I get b times x minus 5, x plus 3. This should look very familiar because it's similar to solving rational equations. and those x plus 3's cancel. So now I have something that has no fractions in it. I'm going to distribute the a. I wrote a3, but really traditionally we put the coefficient first. So I'm going to rewrite this as 3a so it looks more normal to our eyes. And then we have bx minus 5b. And I'm going to just do a little bit of rearranging. I'm going to highlight things for a minute so you can see this 5x is like terms with this x and this x. So if I rewrite this, I could say I have 5x on this side and there's no x in this minus 1, so I'm just going to look at that side as 5x. I know that if I add those two like terms together, I'm going to get 5x. The rest of my stuff is constants. So if I add these things together, I'm going to get a -1. I kind of X things out so it's hard to see, but so I have -1 has to be like 3a minus 5b. Now I still have too many variables, but one thing I could do is I could divide this equation by x, or just say, well, I know the coefficients have to add up to 5, so I don't care that there's an x on them. And so I have this system of equations with two unknowns. It's two different equations, so you could use your calculator and solve this with a matrix. You could also look at this as a system of equations and use your algebraic methods. I'm going to choose to use an algebraic method for this problem. If you choose to grab your calculator, that's okay. But I'm going to choose to use the method of substitution. I'm going to get a by itself. So a is equal to 5 minus b. Now I'm going to put a into the other equation. -1 is equal to 3 times 5 minus b minus 5b. I've now gotten rid of the a, so I'm going to do -1 is equal to 15 minus 3b minus 5b. -16 is equal to -8b, so b is 2. You've done this before, you've done it in algebra, but I'm just reviewing this. And then I can go back to either one of my equations, but I like this first one. Now that I know b is 2, I know that 5 is equal to a plus b. So, well, a plus 2, because I know that b is 2. So I know that a is equal to 3. Just want to remind you about what this means. This means that we have now decomposed this rational expression into two different fractions. The first fraction is going to be 3 over x minus 5, and the second fraction is going to be 2 over x plus 2. I've written it as a rational expression with reduced denominators. The denominators are reduced down to their factors. And I know that these two things are equal because I know that with those two values for a and b, I get 5x minus 1 in the numerator. So that is decomposing rational expressions. I am going to stop here. And if you would like to try the other examples, I will walk through the other examples. But I also have my work posted on Schoology, so you could look at that work as well. Hey, good luck. Let me know what questions you have. You can send me emails if you need to.